Morning class, are you there? Say hello, come on. Everyone, say hello. Then I'll start. Good morning. As usual, we start with a very big smile. Good morning, everybody. Let's see how many of you are there. No one yet? Okay. Pavan, good morning, Pavan. Thank you, Duru. Yeah. Yes, Rupa, good morning. Hello, Duru. Yeah, Kishan, good morning. Yeah. Yes, Amreen. Yeah. Do I start? Today I'm going to do. Good morning, Duru. Guys, Doreen is my sister. Nina, good morning, sweetheart. Shilpi, good morning. Amrin, good morning. Yeah, shall I begin? Okay. Actually, when I revise, I'm also going to do. Now I'm going to give you a problem. When I revise, I'm going to do formulation of the problem. If I go to do the formulation and good morning, Vicky. If I do the formulation and the this thing, what to say, simplex method, it's going to be ridiculously long, which we cannot afford to do in this online. So I'm going to do it straight away. Yeah. When we revise, we'll do the formulation as well. Okay. Okay. Are you ready? But since I've done sufficient simplex problem, I may not go into, excuse me, revision of the simplex problem. Good morning, Hadia. Hope you're doing great. Where is Rashid today? Yeah. Shall we start? The problem is like this. Excuse me. The problem is like this. Maximize Z is equal to Prashant. Happiest morning to you too. 500x1 plus 600x2 plus 1200x3. Subject to 2x1 plus 4x2 plus 6x3 lesser than or equal to 160. Then 3x1 plus 2x2 plus 4x3 lesser than or equal to 120. x1, x2, x3 greater than or equal to 0. So here is the problem. Everybody ready? Okay. First, what do? I standardize the problem. Yashaswini, good morning, ma. Okay, I standardize the problem. How do I standardize the problem? You look at this problem. There is x1, x2, x3. If there is x1, x2, x3, it does not mean I put three various slack variables. Okay, it does not mean. But look at the problem again. How many constraints are there? There are two constraints. So I put only two slack variables. How many constraints are there? so many slack variables I have to put. Alright, so write the standardization. I have already taught you. Just give me a moment. I will write. First one, I just want to see the worked out version. And so, sometimes when I work out, I need support. Okay, so here we are. I'm doing this version. Maximize z becomes, the objective function becomes 500 x1 plus 600 x2 plus 1200 x3 plus, as I told you, the coefficient of the slack variables in the objective function is always 0. So plus 0 s1 plus 0 s2. Alright, now what we have to do is to add s1 and s2. I will add s1 and s2 for both, because you shouldn't say, ma'am, from where s2 came. Alright, actually in the first constraint it will be like this: 2x1 plus 4x2 plus 6x3. Now I'm going to add s1 with a coefficient 1, so it will become just s1 plus s1. Now what you can do is not write s2 at all, but I prefer to write s2 because you will say, from where did the 0 come? So it is plus 0 s2 is equal to 160. See, for s1 I am going to give coefficient number 1. For s2 it will be 0. Alright? Okay, now let's go to the next constraint. 3x1 plus 2x2 plus 4x3 plus s1 0 plus 0 s1 plus s2, you give coefficient of 1 now, plus s2 is equal to 120. So for the linear programming, for L problem, that is LPP, the problem we are going to work out, this is the standardized version. Wait. Alright, once again. Okay, shall we go ahead? Now we are making, you have to find the initial solution, isn't it? For that we are creating the table. So remember what I told you. How many variables are here? You have x1, x2, x3, then you have s1, s2, 5 variables. Alright, including the slack variables, you have 5 variables plus one more column. So 6 always, the number of variables plus one more column you have to do. So we'll rule for 5 plus 1, 6. So the first column, as I told you, you leave the row blank. So first column you leave blank because we want to leave the row blank. And now from this I'm going to rule for 6 columns, and then I have to leave space for 2 more columns, but I'm not going to draw them now because the first row I want it blank. I'm just teaching you how to quickly do the table in the when it's necessary. Rule now: 1, 2, 3, 4, 5, 6. Okay, I have ruled 6 columns and left place over here for 2 more columns. Alright, now only for the ruled columns you have to make a row. Okay, only for the ruled columns make a row. Hanumash, good morning. Nelson, hi Nelson. Okay, yeah. Now rule completely. Second row will be complete. Rule it off. All right. Now for the first 2 rows, shall we do the necessity things? Yeah. What are you going to do here? CJ, right? In the first column, first row. I mean what you have ruled. C to the base J. And below that, basic variable. If you cannot hear me, just tell me. I tend to go softer as I teach. Alright, here are the basic variable and the, okay. Now, C means coefficient of the objective function. So the coefficients are 500, fill, 600, 1200, 0, 0. Why? 0 is 2, S1 plus 0 S2. Below that, write the variables x1, x2, x3, s1, s2. Everybody, hope you have not forgotten what I taught you. Now, let us rule for the first variable. Rule of, now you have to rule for how many rows? Number of slack variables you have introduced. So under basic variable, I will write S1. Then I have another one for S2. Rows that you require are equivalent to S1 and S2. Now let us fill this one, first. Let us fill all the coefficients. For S1, it was 2x1 plus 4x2. So the first constraint I'm filling in S1. Because why? Where the S1 is number 1, right? The coefficient of S1 is number 1 and S2 is 0. So you'll get 2, 4, 6. Under S1, 1 and S2, it is 0. Okay, I'll continue. Obviously, you will have, you know that in the next column, what do? Next row, I fill the coefficients of S2. I mean, coefficients of the second constraint. 3x1, so 3, 2, 4, 0 and 1. So this is done. We come to the first column. See, there is S1 here and S2 here. So you have to fill the coefficients here. Which coefficients? The coefficients of the objective function. So in the objective function, S1 is 0, S2 is 0. So I put here 0, 0. 0, 0. Is that clear? Now, in the last columns, let me fill it up. Rule a line for the columns. and the first one will be solution, and the second will be minimum ratio. Now our table is filled and we are ready. Good morning, Mallikarjun. Our table is filled and we are ready. Those of you who have joined late, please fill the table. I'll give you a minute. Please fill the table and be ready. Okay. Shall we go ahead? Okay, we are ready to work out. What do we work out first? After S2, we have to write below S2 Z to the base J and rule of the last one will be delta to the base J. What is Z? Sorry, what is ZJ class? Yeah, we do 0 into, which is the first one? 0 into 2 plus 0 into 3 will be the value here. Next, 0 into this value plus 0 into this value 2 will be the amount here. Sorry class, to point out it's a little difficult. Okay, then next one, 0 into 6 plus 0 into 4 will be the value here. Again 0 into 1 plus 0 into 0 will be the value here. Similarly 0 into 0 plus 0 into 1 will be the value here. So let us calculate Zj. Zj will be all 0. Okay. Now we have to do delta j. Sorry, something has been fallen on that. Delta j is equal to Cj minus Zj. So Cj is on top. So here you have 500 minus 0 will be 500. Similarly, 600 minus 0 will be 600. 1200 minus 0 will be 1200. So write please, your values will be 500, 600, 1200, 0, 0. Now, our delta values are all positive. 3 delta values are positive. 1, 2, 3. All 3 are positive. So, we cannot have an optimal solution and we have 2 zeros. Our optimal solution will be arrived at when you get 0, 0 or all the negative values, either negative or 0. So that is why now we have to find out the key column. How do we find the key column? Key column will be, if you see here, values of x1, x2, x3. This will naturally be 1 and 0, so it won't be any time greater than what is here. So you have here 2, 4, 6. Note that 6 is the largest number. Next you have 3, 2, 4. Note that 6 is still the largest number. And then, yeah, so we have 2, 4, 6 and 3, 2, 4. Naturally, our 6 will be the largest number. So this one, or x3, will be the key column. It will also be the arriving variable. x3 is key column. Yes, should be good. So I'm just going to, you can make a note, like, can put a like that, a kind of, elongated covering, or you can follow my this thing and just put a thick, very thick arrow. So x3 will be the arriving variable, and 6 we have not found out key element, we have only found out key column. X3 is the key column. Now what do we have to do? I have not put the fill the solution column. I'll fill the solution column. The solution column will be 160 and 120. Now minimum ratio will be this 160 divided by this, the key element in the key column. 160 divided by 6 will be your answer over here. Similarly, 120 divided by, what is this? 4, I think. Yeah, 4 will be your answer over here. So you will get 160 by 6 is 26.67, and then 120 by 4 is 30. Everybody clear? Now I want to find the key row. So minimum ratio is 26.6 versus 30. 26 is lower, so this one is the key row, and this fellow S1 becomes the departing variable. I repeat, 26.6 is lower than 30. We want the minimum ratio. So 26.6 row becomes the key row, and the element here S1 becomes the departing variable. I already told you, when this departs, X3, which is our key column element, should come here in our next iteration table. Our next iteration table obviously is inevitable for us. Yes. So, yes, Shilpi, very good. So, we have an intersecting element. This is the key column and this is the key row. So the intersecting element 6 will be a key element. Alright, the intersecting element of the key column and key row. So I'm going to circle 6 now. Okay, and this particular table is over. Alright, everybody, let's go ahead. Now we have to go and make the second table. Again, class, I would like you to do how I've been teaching you systematically. What you have to do is, first you have to rule, leave one column free, because as I told you, I don't want the row line in that column. Leave one free, and then again you have x1, x2, x3, s1, s2, 5 plus 1, 6 columns. Rule 6 columns, and the first row you rule, call the first one CJ and fill it. I'll show you once again. 500, 600, 1200, 0, 0. There, I've filled the first row. The coefficients of the objective function as you did in the previous table. Now the next row will be ruled completely, and we will finish writing here. The last two row columns also I am ruling, and I am writing their solution. Okay, and minimum ratio I'm writing MR. Alright, let us under Cj we will write basic variable. I will just put BV here. Alright, excuse me. Now again I will rule two rows. Why? We had two slack variables. One is departing, that is S1, and instead of S1 we have to put X3, which is the key column element. So first rule of I have ruled for two elements plus Zj under B1 I will write weight. I'll fill. See, you will notice that I have left the column for S1 empty. I again want to say that S1, because it was in the key row, it became the departing variable. And we need an arriving variable. Excuse me. Arriving variable will be the area variable in the previous column, which was the key element. Key column. This was the key column and X3. So X3 will be the arriving variable. So I'm going to do now here I will put X3. Okay. Now in this column I'm going to fill S2. S2 is 0 and X3 was in the here. This is X1. Let me fill the basic variables in the objective function in the second row. X1, X2, X3, S1, S2. I've filled the second row. This row I have filled. Now look at X. We have here X3 and what to fill here. This one will be the coefficient of X3, 1200. I repeat class. Here S1, S2 will be this one. The slack variable in the objective function, the coefficient in the objective function, S2 will have 0, but X2 will have the coefficient of the objective function, that is 1200. So I'll fill here 1200 and 0. Alright. Now, you know how to work out the key row. Key row has to be divided by the key element. The key element original was 2. You have to divide by 6. So 2 by 6, 4 by 6, like that. Sorry. Now I'm going to fill it. You tell me what I have to fill. I'm going to fill in here and you tell me whether I'm filled it right, because yeah, you remember what I taught you, isn't it? Key row element, old element, minus key column element into corresponding key column element into corresponding key row element divided by key element. Alright, the below row and the above row will be the old element divided by key element. So I get here 0.3, 0.6, 1, 0.1, 0, and the next one is 1.8. Here it is divided by key element. isn't it? 1.8 minus 0.4, 0, oh sorry, the above one k element, minus 0.4 and 1. Yeah, Shilpi, I have given you, yes, yes, Shilpi, 1/3 is 0.3, 2 by 3 is 0.6, then you have 1, yeah, and last it is 80 by 3, you're right, 0, yeah, and so you will get, yes, Shilpi, correct, 26.67, and here below you will get 13.60. Just tell me if these values are correct because I've done it digitally, decimally. I've not given you fractions. I've given like this. I think they are right. Copy quickly. See, if you are not quick enough, then you can copy the values so that I can complete the problem. I intend to do one more problem today. Give me a thumbs up if the values are correct. Alright, I'll show again. Okay, thank you. Thank you, Shilpi. Okay, so now I'm going to do ZJ. If you can see here, ZJ will be 500. Delta J is okay. Now you have to do like this: 1600 into 0.3 plus 0 into 1.8 will be the value here. Similarly, sorry, not 16, this is 1200. I'm reading from the back, man, that's why, sorry. The value here will be 1200 into 0.3 plus 0 into 1.8. 0 is 0, so you will get the value 1200 into 0.3 here. Similarly, for this it will be 1200 into 0.6 plus 0 into this value 0.4 is the value here. For this value here, you have 1200 into 1 plus 0 into 0. For this value here, it is 1200 into 0.1 plus 0 into 0.4. So like that we proceed and we get the following answers. I'll copy from what I've done. 360, then 720, then 1200, then 120 and 0. These are the values that I've got. Okay. Now we'll calculate ZJ. ZJ is this value minus this value. Alright. So what do you get here? 500. Where is 500? Wait, okay. 500 is at 500. Yeah. 500 minus 360. You'll get 140 here. This is how much? 600 minus 720 minus 120 you will get here. Next it is 1200, 1200 minus 1200. You will get 0 here. Please go ahead, I repeat. 500 minus 360 is the value you get here. Next, this value, that is 600 minus 720 minus 120 here. So these are the values you will get. I'll write here 140 minus 120, then you will get 0. 1200 minus 1200 is 0. 0, 0. 0 minus something is 0. So these are the values you will get. Obviously, we still have 140 positive. Yeah, this is negative. These are zeros. So zeros and negative value means optimal solution has been arrived. But we have not arrived in this problem because there's a positive 140 here. So we have to make one more iteration table. Okay, it's okay, Shilpi. You can use fraction since I have worked out and kept, and I don't want to waste time working out again. And when I calculate and teach, no, I can make mistakes when in simple calculation. That's why you can go ahead with a fraction, nothing will happen. It will be the same fraction and decimal, but you can go ahead with a fraction. Okay, some of you like to use the calculators. In the calculators, you don't get fraction, no? If you mentally do, you'll get a fraction. If you don't, you have to use the calculator and then it is a decimal. So both ways, whichever you are comfortable with, you do, the answer will definitely be the same. It has to be the same unless you or I make some small errors in arithmetical calculation. Now, what do we do here? We so we find the key element, key column. Look at this: 0.3, 0.6, 1.8 and 0.4. Naturally, 1.8 is the highest. 1.8 is the highest. See here, for x1, x2, x3, we have 0.3, 0.6 and 1. Which is highest? 1. Next, 1.8, minus 0.4 and 0. Naturally, which is the highest? 1.8 is higher than 1, isn't it? So the highest one becomes highest coefficient which carries becomes a key column. X1 therefore containing 1.8 will be our key column, and that will also be our arriving variable. So here we are, right? Now we calculate the minimum ratio here. We calculate the minimum ratio. How do we do that? Yes, how do we do that? Everybody, divided by the element in this, isn't it? Solution 26.67 divided by the corresponding elements in the key column. So 26.67 divided by 0.3 will be your answer here. Similarly, 13.60 divided by 1.8 will be your answer here. So you get 88.6 and you get 7.5. The minimum, how you got S2? Where is S2? Prashant. That is corresponding row element. See, I've given you the formula, no? Old Prashant. Prashant, this one. This is the formula. You, if I go to explain now, I'll have to go to the first table and explain, and it will be a little. I think what you have to do is see this and I'm sorry, this one. Yeah. After I now you copy the values, Prashant. After I finish the problem, you just go and check. Okay, this is the formula. We have done it in the last two classes, no? If I go back, I'll have to again go to the first table, man. We are going already finished the second table and the third. So please don't be worried. You look at this, you will get your answer. Old value minus corresponding key column value into corresponding key row value divided by key element. Okay. With this, you have got the S2. Right? Now, I'll go ahead. So, we have to, Prashant, now concentrate on this one. It's easy. You don't have to worry. You'll get it. Shilpi also has calculated. So, both of us have got the same one. It has to be same. So, here we are. Okay. Which is the lower minimum ratio? 7.5. So, that becomes the key row. So, which element is there in the key row? Key row, which element is there? S2. So, S2 becomes the departing variable. And which is the key element for us? 1.8. Why? Because it is this is the row, this is the column, and in we have the intersecting variable as 1.8. So 1.8 becomes a key element. Thanks, Shilpi. Good. Complete the problem. Very good. Very good. Shilpi, when you take time off, if anybody calls you, you help. Okay? Okay. Very good. Shilpi has completed the problem. Excellent. Shilpi, it shows that I have taught well. What do you say? Okay. Now again, I'm ruling class. 5 plus 1, 6 rows. Please roll. Please rule for 6 columns in the middle. 6. Okay. Then oh. How much you have to do? 5. I wrote X once. 500. Sorry, guys. I'm just filling the first one. 600. 1200. 0. 0. By mistake, I wrote X1, X2. So it is 500, 600, 1200, 0, 0. Quickly do. And then we make a row. In that, I write basic variable and I write x1, x2, x3, s1, s2. I'm just filling in something. Solution, I'm filling in minimum ratio. Alright, I filled in so much. Now, note down class. In the previous, I told you S2 is the departing variable, correct? So here I still keep x3, but these values will change. Alright, and S2 will be replaced by x1. Why? X1 is the key column element variable, sorry, key column variable, and x1 will replace s2. Okay, s2 is departing, x1 is arriving. Kindly rule the rows. So after basic variable, you write x3, which will remain same but not the values, and under that x1 will come in. It is the arriving variable. If we finish the problem with this, we'll get the answers for x1 and x3, no answer for x2, and x2 will be 0. Alright, now as per what I have taught you, as per what I have taught you, I'm going to fill in the values because I'm not going to calculate now. You have to calculate. One is divided by the key element. Key element is 1.8. So the first values are, just copy guys, you can do that later. 0, 0 0.6, 1, 0 0.1, minus 0 0.1. These are all values I calculated and kept, because every time I cannot finish a problem, I'm feeling embarrassed. And the next one is 1. So this row is the key, this one, we have to divide 1.8 divided by this whole row, old values divided by the key element 1.8. So here naturally 1.8 by this one, 1.8 is 1. So this row will be corresponding old element minus corresponding column element into key row element into key column element, or key column and key row. It's the same thing. A into B is equal to B into A, isn't it? So like that, and this one you will get minus 0.2, minus 0.2, 0, minus 0.2 again, and 0.5. Alright. Now for x3 and x1, here I have to look here. What is x3? x3, so here 1200 comes. x1, here what is it? 500. So I am putting here the coefficients of the objective function. So what do I do here now? 1200 into 0 plus 500 into 1. Here I'll get 500, because 1200 into 0 is 0, 500 into 1 is 1. So 0 plus 500, I'll get 500 here. That is ZJ. Alright. Next, what you see here, I'll just read the values. 1200 into 0.6 plus 500 into minus 0.2. Your value will be 620. Next 1200, next 200, next 130. Shilpi, tell me if the values are correct. Now you have to look at x1 x2 and x3, these values 0, 0.6 and 1, 1, this one and this one. Before that, let us, instead of, why I was telling you those values is to find the key element, key column. But key column depends, finding the key column will depend on delta j. Delta, we'll find out the delta and see whether we get any positive values. If we get positive values, then we have to do one more table. We'll see. Now 500, now delta j will be 500 minus 500, 0. Alright? 0. 600 minus 620, we'll get minus, yes, 20. Alright? Next, 1200 minus 1200, 0. 0 minus 200 is 0. So delta j is 0 minus 20, 0, 0, 0. So this is our optimal solution. Okay? Okay, okay. No problem, Shilpi. So what do I have to do? Here, the solution values I have not written. That is also from how you worked out. 4.10 and 7.5. The solution values, how you worked out the others, you have to work out. Alright, now class, look at this. X3, the value is this one, 41.1. X1, the value is this one, 7.5. Do you understand? And since I have not got x2, x2 value is 0. So I will write here x1 is equal to 7.50. x2 will be 0 because we have not got any value. x3 is equal to 4.10. Alright, these are the values. So now I'll use the objective function, which is 500 into x1, 500 into 7.50 plus x2 is 0, so I'll just put 0, plus 1200 into x3, that is 4.10. So your answer should be rupees 8,670. Did you get the same numbers, Shilpi? Yes. Everybody, are you okay with this problem? All understood? Give me a thumbs up. I'm missing Rashid, man. Where is Rashid? Yeah? X x3 is equal to 24. Okay, Shilpi, we will see. I will recheck my values. I will recheck my values, and if there is anything wrong, I will tell you. All right, I'll recheck my values. All right. What do you want me to do? Do one more problem or take a break for 5 minutes and come back? I think I will take a break for 5 minutes and I'll come back. All right. Bye, class. I'll see you. I'll come back in 5 minutes or say 10 minutes. Don't go away. Within, I think, about 6 minutes maximum, I'll come back. Not 10 minutes. And we'll do one more problem. Meantime, I'll give you that break because Prashant, you verify whether you understood. All right? Verify whether you understood. And all of you who did not understand or who did not calculate, take that time of 10 minutes. Okay. Mallikarjun, talk to Prashant. And okay, 10 minutes I'll take a break. You all also can have, eat something and come. Now I'll stop at 10:45. I'll come at 10:55. Meantime, what you all do is you see whether you eat something, drink something, coffee or something, and then you also understand how, if you did not understand, work out those values, and I'll come back exactly in 10 minutes. It's 10:43. I'll come back at 12 minutes, Mallikarjun. 10:55, I'll come back. Bye everyone. God bless. Keep smiling.